Good afternoon. Today, we rely mostly on technologies such as renewable energy to reduce CO2 from being emitted into the atmosphere. But reducing or avoiding CO2 is not enough. We must remove CO2 from the atmosphere and lock it away for decades, if not centuries. If we want to keep to 1.5 to 2 degrees Celsius by 2050, 6 to 25 gigatons of CO2 per year needs to be removed. Now, this is obviously a massive undertaking, unlike anything we've ever done before. But recognizing these challenges, we've seen carbon removal technologies, including direct air capture, biochar, ocean capture solutions, emerging. Now, the question is, how do we get these solutions off the launch pad and for them to be deployed and scaled? So joining me on today's panel are 4 outstanding industry captains and entrepreneurs who are involved in some of the most exciting carbon removal projects today. So thank you all for joining me on today's discussion. So Jonathan, my first question goes to you. Carbon Direct has a team of more than 60 climate scientists who are advising Fortune 500 companies about carbon solutions that they can adopt. You also have an investment arm that deploys capital to support carbon removal and management companies. So how important are carbon removal solutions to the companies that you're advising? And how are you advising them on building up a portfolio of carbon removal credits?
First of all, thanks very much for the framing. And as you pointed out, we're working with clients on both their carbon reduction and also their carbon removal efforts, and we do not see those things as being inconsistent or in contradiction to one another. Our clients all recognize the need to both reduce their carbon footprints quite quickly, but also that they have a significant amount of residual or hard to abate emissions that need to be removed, consistent with the scientific framing. We really do work with clients across a range of different solutions. Clients are all interested in, as the science dictates, there's not going to be enough of any one particular solution to get to that 20 or 10 gigaton per year scale. So clients are really looking at a mixture of different things. Some are at different cost points. Some have different weaknesses and strengths. So there's different durabilities, for example, within nature-based projects, but they can offer co-benefits. They can come at a lower price point. Other companies and other products people are very, very interested in, even though the current price is high, there's an ability that with smart contracting and technology innovation, you can get that cost curve lower, and you're also paying a bit of a premium for the more permanent, the more durable solutions. And I think the more sophisticated clients really are looking at that balance, looking at that portfolio. And what we try to bring to bear is have expertise in each of the different verticals so we can speak specifically to the value of each of these different types of removal.
That's great. And tell us more about your investment business. So you've been investing in very exciting companies in direct capture, in SAF as well, in hydrogen space. So what kind of solutions excite your investment team?
Yeah, I mean, there's similar quality criteria when it comes to the scientific integrity of the partners that we're looking for. But obviously, when you're looking to invest, you're looking at slightly different criteria that if you're a corporate looking to an offtake, you don't really consider. So the price of the investment, for example, ability to scale, how much capital that type of investment is going to consume over time are all part of the things that we're looking at to make both a commercial return and also to back the best-in-class scientific verticals. So when we're looking to invest, we're looking to invest sort of at that acceleration of the growth curve. So companies that are not in the lab scale, they have real-world production, they have real customers, oftentimes big and sticky customers that will last with them, and they need money to scale. They need money to scale up their business operations, areas of that. The science is proven, but the scale is what is needed. So we're really looking from that prism.
Fantastic. So you're actually putting money to work in these solutions, and that's great.
We are.
Thanks, John. So I think I might just go on to each of the solutions we have here to discuss. And maybe I'll start off with Derek. So Derek, Occidental acquired direct air capture company, Carbon Engineering, for $1.1 billion US, and that's one of the most significant deals in our industry. Very exciting. And your business is currently developing one of the world's largest direct air capture facility today. Very exciting plans that you also announced 70 other projects that you have in your pipeline that you intend to build. Could you just share with us, what are the drivers for Occidental to double down on direct air capture?
So thanks, May. It all started with the formation of Oxy Low Carbon Ventures. We recognized that we had significant experience, 40 plus years of using CO2 as part of our operations. And we felt we could leverage that expertise and start investing in businesses that would help, pave the path for a sustainable energy future. And so we looked at a variety of different avenues, and direct air capture made the most sense, right? We can leverage our expertise in putting CO2 in the ground, sequestering it and keeping it there. Our expertise around monitoring the CO2 in the subsurface, our understanding of the subsurface, and combine that with our capabilities around building large-scale projects, particularly chemical projects, through our OxyChem business. And we realized that this particular investment would be well suited for leveraging that expertise. And really, when we do investments, and I help lead the Low Carbon Ventures investment team, we look for investments where we can drive value, and that's just an example of how we could drive value there. The other piece is that we were looking for a technology. When we looked at the direct air capture space and the various technologies, we looked for a technology that was scalable. We believe that it's important for us to start building these at scale because of the enormity of the challenge that we all face. And so we were looking for technologies that we thought we could deploy in a 1 million metric ton facilities. And for those of you that don't know how direct air capture works, there's, broadly speaking, there's a liquid sorbent-based solution and some solid sorbent-based solutions. And carbon engineering is a liquid sorbent-based solution. We flow potassium hydroxide over an air contactor to pull the CO2 out of the air. By the way, we're one of the largest potassium hydroxide producers in the world. And we take that and run it through a calcium loop, right, to regenerate and form basically a pure stream of CO2 off the back end. It is a chemical process, or a series of chemical processes. And so again, it sort of lends to the expertise around building large-scale chemical facilities. So we felt like the carbon engineering technology was scalable and ready to be deployed, and again, that was what was really important to us. It was important for us to be able to deploy this at scale so we could, one, start learning from it, iterating, and driving the cost down, but two, start working on developing our CDR platform and our carbon markets through our 1.5 business. And so we've been working on our first commercial plant, a 500,000 metric ton plant in the Permian Basin in Texas. And it is due for completion by mid-2025. All of the CO2 that will be captured will be sequestered in a saline aquifer, so not used as part of our oil and gas operations. And we've begun selling CDRs off of that, right? So we have entered into long-term deals with folks like AT&T, A&A, TD Securities, just to name a few. And so it supports our overall goal of a direct air capture business, an end-to-end business that was a complete suite of services, from capture to sequestration to selling of the CDRs. And we felt like this was the technology that could carry us there. Now, I will say that we spend a lot of time looking at different technologies to help us with the cost down efforts. And one of my primary jobs is identifying those opportunities and looking for ways for Oxy to either through investment or partnership or whatever, to investigate those opportunities. But again, I think, you know, we saw carbon engineering as such a critical piece to the overall business that we had to make that decision to jump to the acquisition.
Great. Definitely, DAC does provide a lot of promise for scalability, but just very quickly, I think one of the potential setbacks is that it is known to be energy intensive. Building the plants requires a lot of capital. So how is Occidental looking to lower the price point over time to make it more accessible and for it to scale?
So again, I think one of the critical parts of our strategy is we wanted to get to scale quickly and to learn as much as we can so that when we build all the subsequent plants, we can drive down the cost of capture. I think we also have looked at the elements of the carbon engineering technology and looking at ways where we can improve on some of the processes and do it in a way that can you know, drive down the energy consumption and maybe the thermal requirements. And so we, you know, again, look internally. We've got a whole R&D team now, and innovation is key. And by having this plant built, we're going to be able to you know, test various alternatives to try to again, you know, drive down the cost and maybe reduce the thermal and electricity requirements. And again, you know, my focus is on identifying external innovation, right? Technologies that can help support that. So we believe that there's a pathway to drive down cost, and again, it's, you know, partially through deployment, but it's also partially through technological innovation, and we're working very hard on that.
Okay, great, thanks. It might just turn to Henrietta. So carbon culture takes waste biomass and turns it into biochar. And this process effectively locks away the carbon into a solid form, and it can be kept away for 500, if not 1,000 or more longer number of years. We've also seen a very strong uptake for biochar credits, given that it is known to have high quality, but it's also at a price point that is very competitive with other carbon removal solutions. So if you could just share with us, I think you've seen a lot of interest in heavy emitter industries like agriculture, steel and cement industries today. Why are they taking an interest into biochar?
Yeah, thank you so much, May, and great to be here at this summit. So just to take a step back, I guess we were looking at, since we will need all these billions of tons of carbon removal, what's the most elegant way to do it? How can we get to scale as fast as possible and do it in a way that we don't have to build new energy infrastructure, or we don't need huge amounts of some kind of storage capacity, and how can we do that also in a way that benefits in many ways? And the answer to us was biochar. So nature already draws down hundreds of billions of tons annually into all the crops and forests and all the biomass that you see, but naturally respires it back annually. And that's what we're tapping into and hacking that carbon cycle, where we take waste biomass, put it into our patented reactor that we've been developing over the past 6 years on the back of 10 years of academic research, put it into our reactor and take it to a high temperature. And in the process, we generate solid carbon, which is the biochar. It's over 90% pure carbon. We can hold it in our hand, it's safe, we can send it to a laboratory, so forth. And the remaining bit is turned into high energy syngas, so methane and hydrogen and so forth, that can be used to decarbonize industries. And so we're already in operation. We have 2 pilot facilities. The second one that we built is one of the largest in Europe, only 3,000 tons per year. So that means that the whole industry is in its infancy, but we're working on our commercial facilities. Now, why are heavy emitters such as cement or steel so interested in biochar? Well, we looked into cement a little bit with a grant from the German government, actually, and we found that we can replace part of the cement and the concrete, which in fact would lend to carbon neutral or even carbon negative concrete if we use biochar in the aggregate and also in the key components of it. Now, this is without compromising the strength of it, for example, and it's a nice place to put it for a long time. And for the steel sector, they can decarbonize heavily by electrifying their industry. So implementing electric arc furnaces and so forth, they can drive down 95% of their coal use or carbon use, and so decarbonize. But the remaining bit they actually need carbon for. And that's where biochar can come in as a mitigation tool. So literally for the processes to work, you need carbon. And there, biochar can help lower 85% of the remaining emissions. And of course, with the energy that we're producing, hope to also decarbonize some of their gas usage.
Henrietta, so you are building a plant in Finland currently, and you have great plans to expand in other parts of Finland and throughout Europe as well. And I think one benefit is that you look into siting your plants quite close to where the feedstock is, because that's important. But the question here is, given that you should be locating close to the feedstocks, I mean, is biochar really scalable? I mean, how are you looking to kind of scale across Finland and Europe eventually?
Yeah, absolutely. So right now we have a pipeline of projects mainly in Northern Europe. So Nordics are obviously super quick to decarbonize, and the European trading system is driving everybody to net zero. But in any case, on the biomass, it's a critical component of carbon drawdown and carbon removal. I think some estimates in Nature estimated 2 billion tons of spare biomass. So there are varying amounts of the estimated easy to access biomass waste. Now, what does that mean? It means, for example, sawmills or wood processing industries, paper production. It means all of the food production residues. So in California, we're located behind a nut hulling factory where they process walnuts. And so you can imagine that all the processes in the world that generate our food, which most of the population depends on, is made on land, and so that generates huge amounts of waste. And so by co-locating with these industrial scale processes, we can both help decarbonize their operations by generating the energy back for the processes, but also by taking their waste that would otherwise emit this biogenic CO2. So I think there's a lot of synergies there that honestly we haven't even started to explore yet, and I hope we soon have that problem that the few gigatons of biomass waste are being put to use.
Fantastic. Gaurav, let me just turn to you. So carbon removal requires CO2 capture, storage, and transportation. And seawater is unique that it can do all three at once. And what I understand is that Equatic amplifies this natural ability of the ocean to remove CO2 by leveraging the scale of the oceans and for it to serve as an enormous storage for CO2. So you've made tremendous progress in the past few years, and you have a pilot plant in LA where you are based, but you also come to Singapore very frequently for your plant here in Singapore with PUB. So just tell me, what are the proof points you're looking to demonstrate from your two pilot systems?
Sure. Thanks very much, May. Very nice to be here. Lots of familiar faces in the room since I spent a fair amount of time in Singapore. So really, when we started to build the thesis around Equatic, it was built around the idea that we want to essentially combine capture and storage all into the same step, because capture is effectively the most energy-intensive part of the process. We wanted to leverage a natural system because the problem is large enough that you need a synthetic intervention into a natural system to really be able to make an impact at scale. And the way we thought about this is to really be able to do what nature does. The idea around this is really quite simple. Nature's sort of proven itself for a couple of billion years. We don't have to sort of go back and revisit the handbook. And the idea of what Equatic does is actually quite straightforward. We bring seawater into an industrial facility. We do classical electrolysis. We split seawater in acid and base, and we produce hydrogen and oxygen at the same time. And in effect, keeping in mind that carbon dioxide is an acid, we do some really simple acid-based chemistry to stabilize carbon dioxide in the form of what are known as bicarbonate ions and in the form of calcium carbonate, the same stuff that seashells are made of. Now, when we decided to go out and build these pilot plants, we built them with a super important thesis in mind. We were trying to answer some basic questions around Techno-economics, unit economics, manufacturability, and scalability. And we hear these words over and over and over and over again. The problem is, what we're really trying to trace is actually the trajectory of these numbers as they go to scale. And so this is what we were really trying to ask. Can this be done, and can you really demonstrate at scale? So the long and the short of it is we built 2 plants. We built one in LA, which I'll call as a freestanding plant. We built one in Singapore with the Public Utilities Board that's actually connected into a desalination plant, because we wanted to examine the synergies that are associated with existing industrial integrations. Super important, because it's wonderful to say you want to do greenfield facilities every single time, but we know there's going to be lots of brownfield and semi-greenfield facilities that we want to go out and build. Given that those plants did work out well, actually much better than we thought they would, we're now building a much larger plant. Once again, it's the world's largest, so to speak. Really small, it's a thimble in the bucket compared to the total carbon cycle, so to speak, but the plant, when it comes to scale, will do about 4,000 tons of removal per year. What's important about these facilities, and I think this is sort of the central thesis around it, the management of carbon dioxide is not a technical challenge. It's a technical challenge second. It's an economic challenge first. We're not going to impoverish the world to be able to save it. I think that's a central thesis that we need to keep in mind. And so when we built Equatic, it was built on the premise that the hydrogen production of the process can subsidize the entire cost of carbon removal. This is a central thesis I think we need to keep in mind, and we wanted to really be able to push on very hard, because we know that hydrogen is going to be a super important vector also for decarbonization. And as we sort of went about thinking around that particular mindset, we said, what does it take to come to scale? And so that's what we've been trying to prove.
Yeah, so we talk about scale, and how do we know that what you're doing in ocean capture, ocean carbon removals, does not impact the marine life, ocean life as you scale?
So really important question, Mia. Super, super significant, right? And I think this is where we sort of go back and lean on what it is that we're doing. So we're storing carbon dioxide exactly as nature stores it. So we're not actually changing formatively how carbon dioxide gets stored, right? So this is the first thing to point out. The second thing is, we've made a lot of effort over the last couple of years to make sure that as we really look at seawater as it transits the process, it remains unchanged from the point of entry to the point of exit. So all of the macroscopic chemical parameters of seawater remain unaffected. Super important. Of course, we've gone out and commissioned and what are known as environmental impact assessments to be able to really learn what do we expect here. All that said, I think we have to sort of be thoughtful. We've chosen to apply the philosophy that we need to measure, we need to monitor, and we need to be willing to adapt. The reality is, with lots of things, you really only know whether there's an issue or not as you come up the scale curve. For what we're doing right now, this is all irrelevant, right? So 1,000 tons, 1,000,000 tons, these are really small numbers that nature does not even really notice. You might get to a gigaton, it's still not that big a number, right? But what we need to actually do is we need to sort of measure, monitor, and adapt over the course of the life cycle of the process. That's really where the thinking lies. And so that's what we've been really focused on.
Great. So I hope the audience has a taste of what each of the land, sea, and ocean capture solutions that's available today. But let me just take a step back. So for these carbon removal solutions to work, there needs to be a common framework or standards or governance structure. But as we all know, climate change knows no boundaries. And similarly, a lot of the carbon removal solutions, they have impact across national boundaries or across oceans. So what does it take for us to roll out these solutions effectively? Do we need the governments to come in? How can we do this collectively, responsibly as well? John?
I get the easy question first. It's a very complicated answer. I think that right now we're not, unfortunately, working on like a synthesized global policy, but it is important to note that there is a growing regulatory framework that is generally supportive of carbon dioxide removal. So in the US, for example, 45Q will pay $180 per ton. That's not sufficient to pay for the full cost of DAC, at least not today. But when you add that and low carbon fuel standard revenue from California, it does help get the process going. There are similar types of incentives globally. There's no quite cohesive sentiment yet. So what the market is trying to do is really just figure it out. It's stacking all different types of revenue. So you'll see companies like 1.5 take both voluntary purchases, so big corporates will come in and spend money on offtake, and also receive federal tax subsidies for that. We're also seeing programs like from the US Department of Energy, and we're seeing some similar programs in other governments as well, directly procure carbon dioxide removal. So actually be a buyer, and with that, publish their criteria. What are they looking at when they're buying? And we've seen in the Department of Energy program, essentially a match. So the DOE has gone out and said, we're going to spend $35 million on CDR. It will go up over time. And we encourage corporates to match our purchase, to do the same thing. So you see this patchwork of frameworks that are coming together. It would clearly be easier with one price, and the price of carbon removal sort of capping the overall price of carbon emissions globally, but we don't have that framework. And I think it's really incumbent on the people here to work within the existing frameworks, because if we wait for that, it will be too late, right? We need to learn the technology cost curves now. We need to learn about where the sustainable feedstocks are. We need to get these EPA assessments done now, all in the order to scale that later.
Yeah, so as the European, I can comment that the EU just recently, about a month ago, released the sort of first framework as how they're going to bring removals into the European traded system, or emissions trading system, which is the largest in the world. It's about 850 billion euros today, compared to the voluntary market, which is a few billion. And so now there's a first framework at how they're going to phase in these removals. But a flip side of the coin is that the trading system has helped lower emissions, because the heavy emitting industries and so forth are getting their free allowances taken away. And so it's actually becoming cheaper to decarbonize than to just keep paying the fines for emitting. And that's really, these two things go hand in hand, because we want the removals to be the tail end of after the decarbonization. And speaking to some colleagues in the DOE and so forth, I think the US is looking at doing something very much along the lines. It would be kind of crazy to build 3 different systems. It won't be a regulated. Europe is far more regulatory heavy than the US, but there will be some kind of guidelines, and probably Canada following. The UK, of course, follows the ETS very closely, because they were with the EU writing the whole ETS in the beginning. And so we're seeing these kinds of frameworks coming up around the planet. And of course Singapore as well, with the newest, I believe very recently there was some news on the tax, and how you're planning to also bring the price up, which will of course encourage this behavior. So really good stuff.
Maybe just a few comments to provide. I think there's two things that we really want to consider, right? So we need to consider supply and demand. I think we focus often on the fact that there isn't enough demand, but there isn't enough supply. And I think one of the biggest challenges is supply is far too expensive. If you're ever to offer something that is good and cheap, there are always people to buy it. The problem right now is we have neither good nor cheap. If it's good, it's really expensive. If it's not good, it's really cheap. And I think one of the first things we need to work on is supply. If we can make supply available, I think demand will also co-create itself. And I think that's an important thing we need to keep in mind. The next thing around this is I think we need to think about benchmarking, right? So as an example, when people think about the cost of carbon management, there's this interesting number that someone has pulled out of a hat one day at $100 a ton. This number has no basis to it. It's not guided in the social cost of carbon. It's not guided in thermodynamics. It has no economic basis that actually underlies it. And so, really, the number actually exists because it's the biggest bill that you can get in the US dollar. One of the really important questions we need to really ask ourselves is, what do we think that number really pragmatically should be? And how does that number change as a function of time? If we can actually articulate that number well and ground it in a basis of both affordability, but also ambition of where we are willing for it to be today and where we want it to go, I think it sets benchmarks, not only for technology innovation, which is fundamental to all of this, but also for national governments, and I would say regulated actors, to be able to do something, to be able to guide the evolution of that. And I think that's something that, I think we, the collective we in the room and beyond, really need to be focused on.
Well, that's an important point. What is that optimal, cost of carbon? What is the price that consumers are willing to pay for? And I think that's something that is still undiscovered today. A lot needs to go into there. But I guess given the solutions that we have today on this panel, could you just share with us from each of you how you are thinking about driving down the cost over time to get to the number that you think will allow your solutions to scale? Today, as you rightly put it, John, we do rely on government funding, on blended finance, for example, to make this a lot more viable for consumers. But how are you looking to drive down that cost over time in the medium term by 2030 or in the longer run by 2050?
Yeah, I'll start with that. Again, we have viewed it very important to get to market as quickly as possible with a commercial scale direct air capture plant. And the idea is to learn and really get down the technology cost curve on that front and do it as quickly as possible. We've also, believe that to Gaurav's point, I think, there's fundamentally a supply problem on CDRs. We're as providing an alternative, we believe that we can help, bring CDRs to market in a sufficient volume so that we can help alleviate that supply issue. There's still the issue about cost, and that's ultimately what we're talking about. But we're as we go down the technology cost curve and drive down the cost of capture from our piece, we believe that it's going to be a competitive solution at some point. I don't know when that is. I don't know what that price is. We just don't know. But we've got to get out and start doing so that we can figure that out. And I think that's part of the iterative process that we're all going through. That's just our perspective.
Yeah, so carboculture was part of one of the largest portfolios, or the largest portfolio facilitated by South Pole NextGen. So it was, some of the buyers might be in the room as well, hello. But in any case, biochar is the permanent carbon removal today that's making everybody else cheaper. So I think we're in the sub 200, I'd say, in cost right now, dollar per ton or euro per ton. And by in the 2030s, we want to hit, sub 100 or meet the ETS somewhere there around 2035. So really biochar, again, today is about 87% of all deliveries in the market. So really I see all of these technologies as needed, but perhaps the timeline to market is a little bit different depending on what kind of energy infrastructure you need, what kind of storage needs to be built, et cetera, and what's your cost basis. And because biochar is an energy generating carbon removal today, we can already beat the price of natural gas today, and then in the CO2 removals be one of the cheapest in the market while being permanent and safe.
So we've taken a very particular focus on this, right? So if you think about in general technologies in the space, it's not software and it's not small devices. So you can't run through 10 iterations in 6 months. So what we've really focused on is really making sure that we pin down the energy intensity of the process and drop it as low as possible. Because what that does is if you freeze the energy intensity and drop that to the lowest point, you turn the cost curve compression into a manufacturing problem. So what we really focused on is how do you really manufacture at the lowest fixed cost in the right jurisdictions around the world where you have supply chain completeness, which is a really important thing to be focused on. And finally, how do you really modularize systems? If you take the combination of these three things and you look at them for how we've actually approached it, we're essentially seeing order of magnitude decrements that come about literally within 1 year cycles. This is actually really important, and I'm focusing really on CapEx because CapEx actually drives what's known as the levelized cost of carbon abatement. The CapEx compression is the single biggest thing that you really need to work on. We think that that's actually the only way to approach it. This is the first part around it. The second part that you really want to focus on is operational excellence. Operational excellence is a really big part, and unfortunately, until you've built plants that are big enough, you simply never get it. Pilot plants are great, but for example, the sub-commercial demonstration that we're doing in Singapore is so very important for exactly this reason. It's once plants get big enough, you know how to run them, you know how to operate them, but you also know how to build them. Because the next thing that sort of adds into cost, right? We often focus on capital cost, but the overnight cost of construction is one number. The actual cost of construction is a very different number. And to know how to actually do project delivery turns out to be fundamental to delivering plants at scale.
I'd echo what all the panel said, and in particular, because we're focused on a suite of solutions, when we're working with clients now, one, we're increasingly focused on financing that's available to the different projects. So how can you use a long-term offtake from a credit-worthy offtaker to both secure the actual contract, but also to work to unlock either non-existent or expensive financing and make that cheaper and accessible. That's hugely, hugely important. We also completely agree. Project assurance is another big element of the work that we're doing with clients. We've had clients make, great announcements, pushing, new technologies. It's very exciting, but you have to get into the nitty-gritty of actually building things. So when we look across our team, a lot of the team now has engineering and project assurance background, because we're trying to marry financing structures, offtake, the actual building of the stuff, and also the regulatory framework. And I think as the market evolves, it's starting to recognize you need all of these things.
Yeah, it's a new industry that needs to be developed from scratch. So we have been receiving some questions. So the audience have been quite active. Please feel free to use the QR code to post questions that you might have. But let me just take one or two questions that have since come in. So this question actually relates to a bit of a different angle here. It says, besides the solutions discussed, does geoengineering, such as the placement of orbital mirrors and sunshades to block incoming solar radiation, have a role? What do you think about some of these geoengineering solutions?
I mean, I could start. In terms of what corporate plans, it has no role in corporate plans. So geoengineering, so things like solar radiation, sulfur spraying into the atmosphere, I happen to think are worthwhile research and development, and may ultimately be something that is useful. There are some benefits. It could be, in theory, very cheap. There's also some significant theoretical drawbacks, including changing in precipitation patterns, and there are a lot of governance challenges with that. So interesting area of research. There's been some setbacks in that research recently, including a few institutions that have pulled back research. I think that's probably a mistake. But in terms of our corporate approaches, there's zero in solar geoengineering or any other form.
Are we all in agreement?
Yeah, I mean, I guess
I'd agree with John.
Yeah, I guess we have solutions that are deployable and safe today, and we need to focus on the project financing of bringing those to the first scale, bringing those to the 3 to 5 first plants, after which you can access infrastructure capital. And that's like first thing to do today, alongside all of the work on the decarbonization and everything. And I do see, the further down the line in the 2040s, 2050s, there will be new things that will be deployed, and all of that stuff needs to be researched today. But where the capital needs to flow and where the engineers need to go and so forth needs to be the stuff that we can deploy today, because the climate crisis is here today, and it's gonna bite us within a decade. So yeah, focus on the stuff that we can do.
And read Kim Robinson's book, Ministry of the Future. That's the great solar.
Yeah, just talking about stuff that we can do today. So I think renewable energy, for example, has been around and continue to be important. So we talk a lot about CDR solutions today, but and we were looking for more increasing capital to go into CDR solutions. But will capital that flows into this actually disincentivize activities like renewable energy? Are you going to take away capital from renewable energy, for example?
I'm happy to sort of lead with this. I think there is no either or here. I think the reality is that we're going to need a lot more renewable energy all around the world for a very long time. Of course, it's expanding dramatically, nowhere fast enough, so we're going to always need more. I think we also need to sort of take a step back and really look at one fundamental thing that's important. Renewable energy rollouts are actually not conditioned on the need to do good, and they're not conditioned on a regulatory framework. All of the regulatory frameworks effectively exist all around the world, and the displacement of a fossil electron by a renewable electron is super simple. You literally need to throw a switch. So if you think about this from a financing perspective, I would argue it's much easier to plow money into renewable energy assets, because there's a defined basis of how you raise money and you pay for these projects. You have the equivalent of a 20-year PPA that's sitting around. You don't need to go and construct John's equivalent of a long tenure carbon agreement. And so I don't think that they're competitive. But at the same time, they actually cross-leverage each other. there's lots of potential for renewable energy generation that's going to end up driving lots of CDR facilities. I think the coupled return on investment that actually comes from essentially co-financing these assets actually is significant, and I think that's something we need to be thinking about. So in fact, I would say it's an opportunity, it's not a detriment by any means.
I agree. So I think we need renewable energy to power some of these solutions that we're talking about today. We have an audience poll, so I'd like all of you to participate in it with a QR code which was flashed. So the question for this, and I would appreciate everybody's response, is given the carbon gap that we have to bridge to keep to 1.5 to 2 degrees Celsius by 2050, and if you had $1 billion to invest or deploy into air, land, or sea carbon removal solutions, what would you recommend? Please take the time to choose one answer.
It's going to be put in the one that can cycle the capital back before 2050.
Okay, we're starting to see some winners here.
Movement on the racetrack.
Okay. Land is doing quite well, so it's all of the above. Okay, great. I think we're getting almost there. The answers are kind of settling. Right, so we have land and all of the above. That's quite well. Well, I think those. Looking at the answers, I think definitely we need to leverage what we have on land today, be it nature solutions or biomass that we have available. But very importantly, we still need to be able to harness ocean solutions and direct air capture. But taken into consideration the pros and cons of these solutions, I think all above kind of makes sense. But any quick reactions from the panel today on the poll results?
I think the poll results are spot on. There is no one solution that's sufficient. We're going to need to do it all. I think these things are going to mature at different levels, at different rates, and at different prices. But I think what we also need to be thoughtful about as we sit back is that depending upon the jurisdiction that you're in and where in the world you are, there's some solutions that are better than others. Yeah. I think we need to make sure that we do this local geographical, geospatial analysis, so to speak, in a really thoughtful way to know which solution is right for where we are and at the right point in time.
Yeah, I echo that. I mean, again, I think geography matters and location matters. And so, the ability to scale like a direct air capture facility in the U.S. is much different than it is, in Asia or Europe for that matter. But again, I think it is, in my mind, all of the above. And I think ultimately, capital availability is going to be dictated by, the solutions that you'll provide from an integrity and durability standpoint, the best solution.
Yeah, I think that, every year is such a huge leap in carbon removal and in this space in general, that the life cycle assessments, the project financing, everything matures in huge leaps annually. And so it's going to be really exciting for the next decades as we really kind of start this entirely new way of carbon stewardship in the world. And sort of, this is the early days, so welcome to the gang.
John, last words?
No, I mean, I agree, and as does the science, right? None of these things on their own are going to be able to get to that 10 gigaton per year. So if that's your North Star, you really need to focus on that. And also, like what the panel said, things are heterogeneous within these categories. So when we work with customers, it really is about examining the life cycle assessment of the particular project, the durability of the particular project. This is new, and it does require that type of analysis to really get comfortable. But glad to see people are broadly supportive of a range of options.
Thank you. I think I have to agree to that. So just a couple of quick takeaways. It is still a very nascent industry. I think there are many emerging solutions. We'll continue to see new ones. But we do recognize that there are value propositions and challenges with every solution. But at the end of the day, what we are trying to solve for is scalability and impact. For us, I think for me personally as well, I think we need to take a portfolio approach because we need to support all viable solutions, and we need to also diversify our approach as well to get to net zero. So let's all work together to put that carbon back to where it comes from. Well, thank you so much for joining us today.
Thank you very much.
Thank you.